So here are some examples of using the box method of the chain rule for implicit differentiation. I tell my students that when you're trying to find dy dx, that's implying that y is some kind of quote-unquote function of x or something complicated that involves x. So anywhere there is a y in this problem, I'm going to draw a box. So x squared times y, well, there's a box around that y, and then there's another y over here on the right-hand side, so there's a box around that y. So I'd first draw my boxes everywhere there's a y because it's some complicated expression involving x. So then I do the derivative with respect to x, so diff, differentiate with respect to x. And then I've got a product rule, x squared times y. So the derivative of x squared y is 2x times the y left alone. Plus, now I have to take the derivative of y. Well, there's a box around it, so that is a chain rule problem. So the derivative of y is dy dx. And then I do the product rule times the x squared left alone. And then the derivative of minus 2 sine x is minus 2 cosine x. And then finally, the derivative of the right-hand side, the derivative of y cubed is really box cubed, so it's a chain rule again. So 3 box squared would be the derivative of box cubed. But then because of the chain rule, I need to multiply by the derivative of that box. The derivative of y is then dy dx. And then I backfill that box as a y. And now what I need to do is isolate the dy dx. So I move all the dy dx terms to one side. It doesn't really matter which side. And then I move the other terms to the other side. So I'm going to have 2xy minus 2 cosine x equals, I'm going to factor out dy dx in one step here. I usually don't in the first example, but I will here. 3y squared minus x squared, and then divide both sides by 3y squared minus x squared. So dy dx equals 2xy minus 2 cosine x over 3y squared minus x squared. Here's another example. Once again, anywhere there is a y, it gets a box. So there is a y right here, so box around y. And then there's a y right here, so box around y. And then I notice that I've got tangent of something complicated, so there is another box, in this case a yellow box, around the xy. So it's tangent of yellow box. Now I'd take the derivative with respect to x, so diff wrtx. So the derivative of tangent of yellow box is secant squared of yellow box. Now I need to multiply by the derivative of the yellow box. Well, the yellow box is x times y. That's a product. So the derivative of x times y becomes 1 times and then y left alone plus, and then the derivative of y, well, that's a chain rule, box, so dy dx, and then times the x left alone. And then derivative of minus natural log of x is minus 1 over x. And then the derivative of 4 box squared becomes 8 box to the first, and then the derivative of the box becomes dy dx, so times dy dx. And then I go backfill the boxes, so the green box is a y, and the yellow box is an xy. And then I would distribute the secant squared xy into the expression here, so I'm going to have y secant squared xy plus x secant squared xy dy dx. Minus 1 over x equals 8y dy dx. And now I'm going to put all the dy dx terms on one side. It doesn't really matter which, so this time I'm going to go to the left. So I'm going to factor out dy dx while I'm doing it. Again, when I'm doing it for students, I usually don't do this until later. X secant squared xy minus 8y equals 1 over x minus y secant squared xy. And then I divide both sides to get dy dx equals 1 over x minus y secant squared xy over x secant squared xy minus 8y, and I've isolated dy dx.